Hey folks, this is video number 4 out of section 14.3, and this should be the last video in this particular section. First thing I want to talk about is the special right triangle, and the special right triangle in this particular case is the 3, 4, 5 triangle. Long before Pythagoras ever came up with the Pythagorean theorem, the Egyptians back in ancient Egypt figured out that if they had a triangle that had sides of 3, 4, and 5, it would always give them the perfect right angle. And so they could use this concept in their building if they wanted a right angle in their building. And think all the way back to the ancient pyramids in Egypt or the Parthenon or things like that. This is going to give them the perfect right angle. Pythagoras came along and showed that the 3, 4, 5 actually works. And so if you take 3 squared plus 4 squared, putting this into our Pythagorean theorem, it truly does equal 5 squared. 3 squared being 9, 4 squared 16. So we see that 25 does equal 25. We have some other common what's called Pythagorean triples. 3, 4, 5 is a Pythagorean triple. And there are some other ones that occur. And so 5, 12, 13. So if you have a side of 5, a side of 12, and a hypotenuse of 13, this is a Pythagorean triple. Also the 8, 15, 17, and the 7, 24, 25. Now, I'd like to take a look at the Pythagorean theorem used for the distance formula. Some of this should trigger your memory in previous math classes, but nonetheless, I want you to see that it is nothing more than the Pythagorean theorem. So the distance formula is x1 minus x2, that whole thing squared, plus y1 minus y2, that whole thing squared, is equal to my distance squared. Pythagorean theorem, hopefully you can see that. You have something squared plus something squared is equal to something squared. That's nothing more than the Pythagorean theorem. So I have an example here that says that we are to find the distance from point A to point B, where point A is at the coordinate 7, 4, and I have it over here marked, and point B is at the coordinate negative 2, 1. If I go ahead and connect to the dots, connect these two, I'm trying to find out how long that segment is. So we're going to use the distance formula to do that. So the first thing that I have is I simply copy the distance formula, but then I'm going to plug in my numbers. So you notice that I have the two x values being subtracted, 7 minus the x value negative 2. Let's not forget to square that. And then my two y values are subtracted, the 4 minus the 1. And this is going to equal my distance squared. And then I'm going to just simplify that. So I'm going to have 9 squared plus 3 squared. Now, before I go any further, I'd like you to be able to see that that 9 squared actually makes sense. So think about this in city blocks. Let's say that I'm starting at point B, and that's a building, and I need to get to building A. And so if I'm going to go, I can't go straight through buildings, but I can follow the city blocks. So if I go east, let's see here, 1, 2, 3, 4, 5, 6, 7, 8, 9 blocks. And then I go north, 1, 2, 3, there's my 3 blocks. Notice that 9 and that 3, that's exactly what we have over here in our equation. And so the distance formula is what gives us those city blocks per se. All right, going ahead then and doing my math. 9 squared is 81, 3 squared is 9, and when I add those together, I'm going to get 90. Now I need to take the square root of both sides, and I want to get an approximation for the square root of 90. So I'm going to come down below here, and if I want the square root of 90, the closest square root lower than 90 that I thought of was the square root of 81. And the closest one above 90 is 100. And so I know that the square root of 90 is going to be somewhere between 9 and 10. It's going to be 9 point something. So the next thing I need to do is I need to figure out, it's going to be 9 point what? So I need to see how close is 90 to those other two numbers. So I know that the distance from 81 to 90, that's only 9 units apart. but the distance from 90 to 100, that's 10 units apart. So it's a little less than halfway. So I'm going to say that this is approximately 9.4, so that my distance is 9.4 approximately.